Okay, everybody, welcome back to Network Security. Today we're going to be talking about Module 15 and 16, Cryptography 1 and 2. So it's just basically separated into two modules in Cisco Networking Academy. First module talks about the basics of cryptography. Second module keeps talking about cryptography and some technologies that we have in cryptography and also encryption technologies. So I basically combined them both into a single session. We're still going to be delivering both modules though. So we're going to do module 15. After we finish it off, we're going to have a 10-minute break and then we come back, smash it out the second module. Let's get started. So module 15 is basically divided into a few topics. The first topic is talking about secure communications. Then we're going to jump into cryptography, cryptanalysis, cryptology, and that will be all for this module. Let's get started. Securing communications. Now, here's just basically what we've been discussing throughout the whole semester. So in the first few weeks, we basically talked about the importance of the CIA triangle. So some textbooks call it triangle. Some textbooks call it triad. It just basically means the same thing. We've got these three pillars of network security. They include authentication, integrity, or confidentiality, or CIA if you start in confidentiality, integrity, and then authentication. This will basically dictate to us what we expect from a secure communication. So the first one that we need to talk about is confidentiality. So we discussed about confidentiality throughout the whole semester, but confidentiality basically means that unauthorized users, unauthenticated users, they won't be able to make sense of the actual data that we are sending or receiving or the data at rest. And that is thanks to encryption. So we've been talking about encryption. We've been seeing some examples about encryption, but we haven't actually discussed much of how encryption works. Encryption relies on cryptography to work. We also have integrity. So integrity, as we mentioned before as well, is just basically making sure that the actual data is integral. The actual data hasn't been tampered. The actual data hasn't been modified going from point A to point B. So integrity is extremely important for making sure that unauthorized users haven't modified the data, and that would be it. So there's actually a way for us to double check if that was the actual data being sent. We also have authentication, of course, which is just basically making sure the users can authenticate. Right? Now, there are two primary methods of validating a source in network communications: authentication services and data non-repudiation services. So basically, when we have authentication services, we want to verify someone's identity. So we just want to make sure, oh, you're Robert. Can you prove to me that you're Robert? Can you maybe show me your driver's license? Or can you maybe show me your passport or something like that? Now, data non-repudiation is a similar service that allows the sender of a message to be uniquely identified. So with non-repudiation services, a sender cannot deny having been the source of that message. So there is no way you can deny that you were not the one that originated the traffic, that hasn't been sending the data to the destination. So with non-repudiation, there is no way someone can deny that they haven't done certain things. Okay, and we'll see how we can do data non-repudiation very, very soon. Now, data integrity, as we already mentioned, data integrity ensures that the message is not altered in transit, hasn't been modified, hasn't been tampered with, misleading information, or hasn't been changed, and the meaning is still the same. All right. Now, data confidentiality, as we already discussed, data confidentiality ensures the privacy of the information, ensures that even if someone takes hold of the data in transit, they are not going to be able to make sense of it. And that is because it's being hidden. So this is only achievable through the use of encryption. So when enabling encryption, the readable data is called the plain text or clear text. And after we process this clear text, and we transform it into the encrypted version, we're just basically using the encryption algorithm to do that. And it just basically means that if someone doesn't have a key to unencrypt the actual data, there is no way that they can view the contents of the packets or frames as they go from point A to point B. Now, in terms of hashing, hashing should never be confused with encryption. Okay? Hashing is another way to ensure confidentiality. But the thing is, hashing is mostly used for data integrity purposes. So that basically means to make sure that the data hasn't been modified, hasn't been altered. Now, the difference between hashing and encryption is how the data is stored. Now, with encryption, we are basically going to process the entire data through the encryption process. And there is a way we can get the information back. So it is encrypting it and unencrypting it. These two things are important. In terms of hashing, hashing is considered to be a one-way function by many textbooks. And that is basically because mathematically speaking, it is nearly impossible or even impossible for you to get the actual data if you just have the product. Okay? If you just have the hashed information, you cannot get the actual data. Okay, so it is mostly used for verification purposes. So sometimes when we download a certain file from the internet, I don't know if you guys noticed that before, but you download a certain file from a reputable website, it also comes with hashing. So it just basically says MD5 or SHA or whatever that is, and it's just basically the hashing of these actual data. Now, once you have the actual data and the result of the hash, you're going to take the actual data, execute the same hashing function as the source, and then you compare the two results. If both results are the same, that basically means that the data hasn't been tampered, hasn't been modified in transit. And that is how hashing works. Encryption is not like that. Encryption, you send only the encrypted version of your actual data at the destination. The destination will use the key that it has. So if it is symmetric key, you would just basically use the same key. If it's asymmetric key, it relies on public or private keys to encrypt or decrypt the data. All right. Cryptography. So cryptography just basically worries about making sure that data is not visible by unauthorized users, by users who are not supposed to be viewing the message. Now, this is one example of a ciphertext. So you basically have a normal text, you type a certain letter, but it basically takes that letter and substitute that letter for another specific letter. And then this concept has been part of human history for a very, very long time. If you don't want anyone to just basically easily read the message, you can cipher it. So you can basically masquerade it. You can put a mask on the message so that the person will not easily read the message. Now, this is an example of one of these sort of machines. This was the Enigma machine, which was an electromechanical encryption device that was developed and used by Nazi Germany during World War II. The device depended on the distribution of the pre-shared keys that were used to encrypt and decrypt the messages. So basically, if you didn't have the key, it was nearly impossible to basically decrypt the message, right? It's been used by the Nazis, and it was really hard to beat the Nazis on the Second World War because of this, because all the messages that they were sending and receiving to and from each other were basically being encrypted by this Enigma machine. All right. So basically, the Allies, when they started to try to find ways to defeat Germany, they actually realized that they had to crack this code. Okay. So there's actually how the computer was created pretty much, because at the time, this guy came in and he was hired, I think, by the UK government or something like that, England, to crack this code. And he started creating the Turing machine. So there's actually a nice movie that you guys can watch about the story of the Turing machine and everything else. Let me try to see if I can find the name of the movie. So the name of the movie is The Imitation Game. Yeah, so it's Benedict Cumberbatch. So if you never watched this movie, mate, that is an absolutely amazing movie. And you will see that the Nazi Germany was actually using these sort of devices. And basically the Allies' job was to find out a way to crack this sort of machine. Yeah. Okay. So it's basically the story of Alan Turing and how the Allies found out ways to crack the code of the Enigma machine. All right. Now, transposition ciphers. Now, in transposition ciphers, no letters are replaced. They are simply rearranged, transposing. So basically taking one thing and replacing it by another thing that already exists. So you're basically swapping the position. All right. So this is an example of a transposition cipher. All right. So for example, you have a text, a plain text, flank east attack at dawn. And you can basically do some sort of transposition. For example, swapping the FLAs and making changes to the order of how things are displayed. So if someone, instead of seeing the flank east attack at dawn, they will see something like that, okay? Which is extremely weird for someone to find out what that is. So another example of a transposition is also known as the rail fence cipher. In this transposition, the words are spelled out as if they were a rail fence. All right? They are staggered, some in front, some in the middle, and some in the back, across several parallel lines. An example is shown in the figure. Okay? Modern encryption block cipher algorithms such as AES and Legacy still use the transposition as part of the algorithm. Right? So this is just basically explaining to us how things work. So instead of just displaying the plain text as it is, you can do some sort of hidden process of modifying the position of certain letters, modifying the position of certain characters. And that would basically mean someone that doesn't know how this was done, how the process was done, would have a very difficult time trying to find out how people actually done that. Substitution ciphers are another type of cipher that basically substitute one letter for another. So we have a simplest form, substitution ciphers. They retain the letter frequency of the original message, but instead they substitute a letter for another. If you don't have the mapping for which letter replaces another, it is extremely hard to find out what the message is about. Okay. So there you go, substitution ciphers. So transposition, substitution. Now, of course, there are many, many more complex substitution ciphers. Some of them will actually use much more difficult techniques. So the Vinegar cipher is based on the Caesar cipher. So except that it encrypts text by using a different polyalphabetic key shift for every plain text letter. So the different key shift is identified using a shared key between the sender and the receiver. And then the plain text message can be encrypted and decrypted using the cipher table. So we have a cipher table, something like that. And both the sender and the receiver, they have a shared key that is then used to encrypt and decrypt the message. Of course, we have way more complex substitution ciphers. Okay, this is an example of the Vigenère cipher that we just talked about. We could have a shared secret, that's the plain text, and this would be your ciphertext. Okay, so you can basically put those values in the table, okay, and find out what the ciphertext would be. One-time paired ciphers. So Gilbert Vernon, that used to work for AT&T Bell Lab engineer, he was in 1917 and invented a later patented the stream cipher. He also co-invented the one-time paired cipher. He proposed a teletype cipher in which a pre-shared key consisting of an arbitrary long, non-repeating sequence of numbers was kept on a paper tape. So you had the paper tape. It was then combined character by character with the plain text message to produce the ciphertext. So just another way we could produce ciphertexts, okay? And just basically hide the original message. All right, having said that, what is cryptanalysis? Cryptanalysis is the practice and study of determining the meaning of encrypted information. In other words, cracking the code. So now we studied some ways we can hide, we can encrypt the code. Now, cryptanalysis is interested in finding out how you could possibly get the message back without the access to the shared key, okay? Also known as code breaking. Now, throughout history, many different algorithms, they were found to be vulnerable. In other words, cryptanalysis were able to crack them, okay, and find out what the actual data was, the actual information was, the plain text was. So there are many methods for cracking codes and doing cryptanalysis. The first one of them is through brute force method. What does that mean? All right, you want to find out what the data is. You know the result. You know the type of encryption algorithm. So maybe you can just give it a try and try as many times as you can. And you can try different combinations of data. And once the data produces the same ciphertext, that basically means you cracked it through brute force. Okay. So he tries every possible key, every possible combination to try to find out the cipher algorithm and how it works. Another way of cracking and doing cryptanalysis is ciphertext method. So the attacker has the ciphertext or several encrypted messages, but no knowledge of the underlying plaintext. So once the attacker has the ciphertext of several encrypted messages, he can try to guess which one corresponds to that. There are also non-plaintext method, where the attacker has access to the ciphertext of several messages and knows something about the plaintext underlying that ciphertext. So if the attacker knows some information about the actual data, it is going to be much easier for him to crack the code. We also have chosen ciphertext method, in which the attacker chooses different ciphertext to be decrypted and has access to the decrypted plaintext. And of course, we also have meet in the middle method, where the attackers know portion of the plaintext and the corresponding ciphertext. These are all techniques that can be used for cracking codes and doing cryptanalysis. All right, cracking code example. So whenever we're choosing a cryptographic algorithm, it is really important to understand if that cryptographic algorithm has been cracked before. Right? So when choosing a cryptanalysis method, we need to consider the Caesar cipher encrypted code. The best way to crack the code is the use of brute force. All right? Of course, the longer the key, the more complex the encryption algorithm that we use, the harder it is to do some brute force. Okay? For instance, if you increase the size of a key, it's going to be extremely hard to try all the possible combinations. It will take ages, years, and so on. All right? Cryptology. Now, cryptology is the science of making and breaking secret codes. So if cryptanalysis is trying to break it, cryptology is trying to make it. Okay? So cryptography is the act of using the codes and the fact that we are now encrypting the actual data, trying to hide it. Okay? And cryptanalysis, the breaking of those code. They always walk together. Okay? Cryptography plus cryptanalysis, both of them combined results in cryptology. Because if you are able to encrypt it, and once you send the actual data at the destination, there has to be a way to decrypt it. So there has to be a way we need to find out what the actual data was at some point. Okay. So not only cryptanalysis is just attacking and breaking, but basically having the techniques to get the data back, okay, by authorized users, authenticated users. So cryptanalysis is often used by government, military, and diplomatic surveillance, by enterprises in testing the strength of security procedures, and also by malicious hackers in exploiting weaknesses in websites. If you want to understand cryptanalysis, you basically understand the art of cracking codes, and you understand how things work. You understand how encryption works, and you understand that there must be a way for you to get your data back if the data is encrypted. So it's just trying to find a way to crack the encryption algorithm and find out what the process to encrypt the data was. Okay. Cryptanalysts, they are individuals who perform cryptanalysis to crack secret codes. A simple job description is displayed. So while cryptanalysis is often linked to mischievous purposes, it is actually a necessity. It's an ironic fact of cryptography that is impossible to prove that any algorithm is secure. So there's no such thing as 100% secure. We talked about this in the first few weeks. In cybersecurity, there is no 100% safe. All right? So it can only be proven that it's not vulnerable to known cryptanalytic attacks. Okay? So every once in a while, these cryptanalysis, they will check all the cryptographic algorithms that are being used, all the cryptology techniques that are being used, and they will try to prove that currently no one is capable of cracking that code simply. Okay? The secret is the keys. So in the world of communication and networking, authentication, integrity, data confidentiality, they're implemented in various ways and using multiple protocols and algorithms. The choice of the protocol and algorithm varies based on the level of security required to meet the goals of the network security policy. So we have a table here identifying some of the protocols that are used for integrity, authenticity, and confidentiality. So for integrity, we have MD5 and SHA. MD5 is considered to be legacy. It's not recommended in the industry anymore because there are some cryptanalytic techniques and tools that can crack the code that was created using MD5. Now we have HashMac MD5, HashMac SHA-256 for authenticity, RSAs and DSAs as well. And in terms of confidentiality, which is just basically pure encryption, we have DES, triple DES, and AES. DES, triple DES, they are not recommended anymore. They should be avoided at all costs because they're considered to be legacy. They were found to have some common vulnerabilities which can be exploited through cryptanalytic tools. Okay, so forget about pretty much anything which is MD5 or triple DES. Right? In terms of AES, the recommended key size, key length is at least 256. Okay. There is a lab for us to explore encryption methods. Okay. And now we talk about the chapter summary for Module 15. Basically discussed about the three primary objectives of securing communications, the CIA, confidentiality, integrity, and authentication. Authentication may be secured by using HashMac. Integrity is ensured through the use of SHA family of hash-generating algorithms. SHA, SHA-256, SHA-384, SHA-512, Of course, the higher the key, the better. Okay. Data confidentiality is guaranteed through the use of symmetric encryption algorithms such as AES or asymmetric such as RSA and PKI. RSA and PKI are widely used in HTTPS websites, okay, in which we have a public key infrastructure, a private and a public certificate, and that's how encryption and decryption works, which we're going to be talking about in module 16 in depth. Authentication proves the message actually comes from a valid source. Data non-repudiation will basically guarantee that the source cannot deny it was the actual sender. Data integrity ensures the message hasn't been altered, and we saw that that's been achieved through the use of hashing algorithms, MD5 and SHA. All right, data confidentiality is guaranteed through the use of encryption. All right? And we then talked about cryptanalysis. So we first talked about cryptology, cryptanalysis, and that was all that we talked about today. All right. These are the new terms and commands we need to learn. So there are no commands, no Packet Tracer Lab for this. It is just a matter of understanding the terminology of encryption and encryption algorithms. All right. So understanding that there is a huge difference between encryption and hashing. One is a one-way function. The other one has to have these algorithms that allow you to encrypt and decrypt your actual data. All right. That will be all for module 15. So we're going to have a break.